Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello everyone. It's great to have you here. To kick off our discussion, could you provide some insights into the foundational concepts of graph-based RAG approaches and how they enhance the retrieval and generation of information of informational methodologies?
Graph-based RAG approaches are like having a treasure map that shows not just where the treasure is, but also all the paths and relationships that lead to it. This is different from traditional methods that might just give you a simple direction, like saying go straight to the treasure. In graph-based RAG, data is organized in a way that highlights the connections between different pieces of information, much like a spider web where each strand links to another. This structure allows for more detailed and context-aware responses to questions. For example, if you ask about a recipe, a traditional RAG might just give you the steps to make lasagna. However, graph-based RAG would explain not just how to make it, but also why certain ingredients are used together and what flavors they create. This is achieved by importing data and using graph query algorithms, which act like skilled guides navigating through a complex landscape of information. By employing these methods, we can develop real-time applications that understand and respond to questions more intelligently. This means users can get richer, more nuanced answers that draw on the relationships between various data points, rather than just straightforward fact.
That's an excellent analogy. Could you elaborate on how Microsoft GraphRAG and Neo4j LangChain specifically implement these graph-based principles? What unique techniques do they employ to extract and utilize the subgraphs for answering complex queries?
Microsoft GraphRAG and Neo4j LangChain implement graph-based principles in unique ways to enhance how they find and utilize information for answering complex queries. Microsoft GraphRAG employs a function called graph retriever. This function acts like a skilled librarian searching through a vast library of interconnected books, looking for relevant pieces of information based on a user's question. When someone asks about a topic, the graph retriever dives into the knowledge graph it has created, identifying relationships between various data points. For example, if someone inquires about drug interactions, this tool can explore the connections between different drugs and diseases, piecing together a context-rich response. After gathering the relevant information, it uses a language model to turn that knowledge into a clear, easy-to-understand answer. On the other hand, Neo4j combined with LangChain uses specific graph algorithms to enhance its retrieval capability. Think of Neo4j as a party planner who understands the dynamics of social groups. It uses algorithms like PageRank or community detection to identify clusters of related entities, much like grouping people at a party based on who interacts the most. LangChain then steps in to pull these subgraphs from Neo4j, which are like focused sections of the larger graph that hold the most pertinent information for the query at hand. This combination allows it to generate answers that are not only relevant, but also draw from the nuanced relationships between the data points. Together, both methods show how graph-based approaches can significantly improve the depth and quality of information retrieval and generation compared to traditional methods.
That's a fascinating comparison. Could you describe the specific algorithms used by GraphRAG, such as the global search and local search, and explain their roles in retrieving relevant subgraphs? Additionally, how does the Leiden algorithm contribute to identifying well-connected communities within the graph?
GraphRAG uses two important search methods, global search and local search, both of which help in retrieving relevant subgraphs to answer user queries effectively. Global search is like having a wide-angle lens that captures the entire landscape of information. It examines the entire dataset to identify main themes or patterns. This is useful for getting a broad understanding of the topic at hand. The method organizes and processes large amounts of data to find connections between various entities across the entire graph. On the other hand, local search zooms in on specific areas, much like using a magnifying glass to focus on a particular detail. This method retrieves relevant subgraphs based on the user's specific query. It hones in on the precise relationships and connections that are most pertinent to the question being asked, ensuring that the response is not only relevant, but also detailed. The Leiden algorithm plays a crucial role in identifying well-connected communities within the graph. Imagine you're at a big party where everyone is chatting. The Leiden algorithm starts by grouping people based on who they talk to the most. If two people frequently interact, they get put in the same group. Then, it fine-tunes these groups by checking if anyone fits better in a different group, like someone moving to a more interesting conversation. Finally, it looks at larger groups and splits them into smaller ones if needed, while merging groups that have strong internal ties. This way, it forms tight-knit clusters of nodes that are closely related. The Leiden algorithm is generally more effective than older algorithms, like Leiden, because it builds more stable and well-connected groups, making it easier to navigate through the complexities of the graph. Overall, these algorithms work together to create a rich and structured environment that allows for nuanced and context-aware responses to user queries.
That provides a compelling overview of the retrieval mechanisms. Could you also explain how the batch search method in GraphRAG operates? What are the key configurations and parameters necessary for running this method effectively? And how do they contribute to the overall functionality?
The batch search method in GraphRAG functions like a powerful search tool that allows users to ask questions about a large dataset through a command line interface. This method is essential for querying pre-indexed information efficiently. To operate the batch search effectively, several key configurations and parameters need to be set up. 1. Root directory. This is where your indexed dataset is stored. The command specifies the path to the folder containing the data. This tells the system where to look for the information. 2. Search method. You can choose between global and local search. Global search looks at the entire dataset to find overarching themes and relationships, while local search focuses on specific sections to retrieve detailed information about certain entities, like laws or forces in mechanics. 3. Query command. The command uses a specific structure to ask questions. This command is crucial as it determines how the system will interpret and process your question. 4. Data handling parameters. Parameters like max, data, tokens, concurrent, coroutine, and response type help control how much data can be processed at once, how many queries can run simultaneously, and how the responses are formatted. For example, allowing multiple paragraphs in responses provides more detailed answers. These configurations contribute to the overall functionality of the batch search by ensuring that queries are targeted effectively, whether for broad themes or specific detail. This flexibility helps users obtain meaningful and relevant responses from the graph, enhancing the overall efficiency of the retrieval process.
Thank you for the detailed explanation. Finally, could you discuss the broader implications of using graph-based RAG approaches like Microsoft GraphRAG and Neo4j LangChain? How do they advance the state of information retrieval and generation? And what potential applications could benefit from these methodologies?
Graph-based RAG. Approaches like Microsoft GraphRAG and Neo4j LangChain represent a significant leap forward in the fields of information retrieval and generation. These methodologies leverage structured relationships among data points, which enhances the depth and relevance of the responses provided. One of the primary implications of these approaches is their ability to deliver context-rich answers. Traditional methods often offer straightforward answers, but can miss the nuances that come from understanding the relationships between different pieces of information. For instance, when discussing family dynamics, a traditional approach might summarize activities without capturing the emotional depth or the connections that strengthen relationships. In contrast, graph-based methods can illustrate how those activities contribute to family bonding, providing a richer and more meaningful response. The potential applications for graph-based RAG approaches are vast. They can be extremely beneficial in fields such as healthcare, where understanding the relationships between treatments, diseases, and patient outcomes is crucial. For example, using these methodologies, healthcare professionals could better analyze drug interactions or the effects of various treatments based on intricate relationships within the data. Education is another area where these approaches could shine. By utilizing graph-based retrieval, students could receive more comprehensive explanations of complex subjects, as the connections between concepts can be made clearer. This can lead to deeper understanding and retention of information. Additionally, sectors like customer service and business intelligence can utilize these advanced methodologies to provide tailored responses based on the intricate relationships between customer queries, preferences, and product offerings, leading to improved user satisfaction and decision-making. Overall, the adoption of graph-based RAG approaches advances not only the efficiency of information retrieval, but also enhances the quality of generated answers, making them more applicable and beneficial across various domains.
Thank you all for joining us today. I hope you've enjoyed this insightful discussion on graph-based RAG approaches. Let's recap the key takeaways. GraphRAGs organize data as interconnected graphs, enabling comprehensive information, retrieval, and generation. They utilize graph search algorithms and natural language processing to extract context-rich answers by leveraging data point relationships. These approaches have made significant advancements by providing detailed, nuanced responses. Their applications extend to various fields where understanding relationships is crucial, such as healthcare, education, customer service, and business intelligence. These approaches are transforming the way we access and generate information, and I'm excited to see how they continue to evolve and impact our lives. Once again, thank you for your time and participation.